Now let's see the next scheduling algorithm known as round robin scheduling algorithm. Okay, it is a very popular scheduling algorithm and it is used in most of the OSs today. Okay, even Windows, Mac, all these OSs today use the round robin scheduling algorithm. Okay, it is very popular today. Fine. Before seeing round robin scheduling algorithm, let's first understand what is meant by time quantum. Okay, what is meant by time quantum? Maximum allowable time a process can run without getting preempted. Okay, see what we generally do is in case of when we are actually drawing the Gantt chart is we will be executing whenever we start with process P1, we will either execute it completely until execution, or whenever a high priority process comes we will preempt it and then we will execute the new process, right? For example, if P1 is executing, either we execute P1 completely or we will preempt P1 because some other high priority process has come and then we will schedule some other process, say P2, right? That's what we have been doing it so far. But coming to round robin scheduling algorithm, that is not the case. It uses something called as time quantum, which means, see, you want one more important point. Round robin is a combination of time quantum plus first come first served. Okay, which means it uses first come first served scheduling algorithm, that is fine. But in case of first come first served scheduling algorithm, whenever we start a process, we will complete its execution, right? But we don't do it here. We execute it only for one time quantum. Let us assume time quantum equal to 2 time units. Okay, if time quantum equal to 2 time units, then we cannot execute a process more than 2 time unit without preemption. Okay, which means whenever we start with process P1, we will execute it for 2 time units. Then what we will do is we will execute the next process. Which will be the next process? The next process which has arrived to the RAM. Why? Because we are using first come first served scheduling algorithm, right? So we will take the next process and then we will execute the next process for 2 time units. Then we will take the next process as per first come first served and then we will execute it for 2 time units. That is what we will be doing. Okay, so it is a combination. Round robin scheduling algorithm is a combination of time quantum and first come first served. See, if you don't understand, still fine, because we are going to solve problems. Okay, after solving problems it will be very clear. Okay, fine. It works on the basis of a particular time quantum. Our time quantum can be either 2 time units or 3 time units or whatever. Okay, fine. It uses a queue data structure. Okay, so what is meant by queue is insertion. Queue is actually kind, you can think of it like an array where insertion will happen at the end. Okay, this is also called as a front end of a queue. Okay, this is also called as a rear end of a queue. Okay, this is called as a front end and this is called as a rear end. Insertion will always happen through the rear end. Okay, in case if I wanted to insert P1, I can insert it through the rear end, which is P1. In case if I wanted to insert P2, I can insert it through the rear end, which means I can insert P2 only over here and not over here. Okay, this is front end. Okay, whereas deletion will always happen in the front end, which means I can delete P1. Before deleting P1, I cannot delete P2. Why? Because in the front end we only have P1. Similarly, insertion can happen only here and not here or here. Okay, that is what we mean by queue data structure. But the queue data structure is actually is very popular in actually data structures and algorithms topic. But let's see only the basics. Okay, that is more than enough to understand round robin scheduling algorithm. Fine.